23rd of April, higher plus 5 a day, and let's just go straight to the first one. Okay, so it's a nice straightforward algebraic fraction. Now, I've made this point in other videos, I'm going to say it again. Now, the fact this exists as a question suggests that you should be able to simplify something. So I'd be very surprised if I factorise the one quadratic, factorise the other, and one of the linear factors didn't cancel somewhere. Moreover, I'd actually go a stage further, which is, because I know that's probably true, I can factorise one of them to help me factorise the other one. So let's first of all just deal with the quadratics themselves. So if I start with this one here, if I try and factorise this one, so usual steps, so I've got 3x, I've got an x, and then 14 is probably going to be 7 and 2, isn't it? So let's think about what I've got. Well, 1 times 7 minus 6 is minus 1, so therefore I need to take away 7, and I need to add 3 times 2, and so that's going to give me 3x minus 7, x plus 2. If this is the first time you've watched one of my videos and you're thinking, well, how did he do that? A bit of experience, a bit of practice, but also the more of these you do get better at it. So just practice them as many times as you can. It will come to you. On this one down here, so similar idea. So it's undoubtedly going to be 2x and x. So I'm going to put my 2x, my x here. Now, I can use this as my guide. I could guess, without doing anything else, it's probably going to be x plus 2, because I suspect the x plus 2s are going to cancel. But let's try and think about what I'm going to use here. So 10 is going to be minus 5 and minus 2, one of those being a plus, but I don't know which one. So I'm just going to guess, based on the previous answer, it's going to be x plus 2, which means that this is probably going to be x minus 5. Quick check, so 2x times 2 is going to be 4x, minus 5x is minus x, and that is indeed what I want. So let's now put this all together as one single fraction. Well, 1 over 3x minus 7x plus 2 means it's going to be in the denominator 3x minus 7 over x plus 2. Then I've got to divide here, so it's going to be keep, change, flip. So in other words, I'm going to put these linear factors on the top. So I've got 2x minus 5 and x plus 2. And there we go. I can see straight away that my x plus 2s are going to cancel, which leaves me with my final answer as 2x minus 5 and 3x minus 7 as a fraction. And I've simplified it fully. I can't do anything else. I can't cancel the x's. I can't cancel any other numbers. So that is my final answer. Now, if you have, and it's probably going to take you a couple of minutes, you've got a couple of minutes in the exam, put a number into here, put a number into here, and they should get the same answer. So you can always check that. But either way, that is my answer to my first question. Next question. The area of ABC. So it's a triangle area question. And as with all questions in GCSE, what do I know about areas and triangles? Well, there's no right angle, so therefore I'm going to use half AB sine C. It might be the case that you haven't come to this yet, because it's often the last thing that teachers teach, depending on what your scheme of work looks like. But either way, I'm going to use the idea that the area of any triangle is going to be half times the 2 sides times sine of C. Except this one's back to front, because this one, I know what the area is. So I can set up an equation. I can say half, and I'm going to call this x, just so I've got something to write. I'm going to say a half times x that I don't know, times 10 that I do know because it's on the diagram, times sine of 50 is equal to 22.981. Now, this is not always the case, but I would suggest to you that because that is some strangely specific number, it's probably going to be the case that x is a nice round number. So let's try and work it out. So let's rearrange. So that means x is equal to 22.981 divided by a half times 10, which is obviously 5, sine of 50. Calculator out. And that's telling me 5.99999, which suggests to me that when they did the rounding here, that they had to round it from more decimal places. So I'm pretty happy with 5.9999, that I'm just going to call this 6.000. But of course, that's not the question. So always go back and double check the question. The question says, calculate the length of AB. So now I know a side, I know an angle in between. This is going to be the cosine rule. So let's set the cosine rule up to do this. Now I'm going to do it in one go. The cosine rule is one of these things you need to make sure you learn. It is going to be the 2 sides squared and added together. So in other words, it's going to be 6 squared plus 10 squared. Take away 2 times the sides multiplied together, 6 times 10, and multiply that by cos of the angle in between them, which are going to be cos 50. Now, I have said this in other videos, I'm going to say it again, even if you're just watching along to see how I do it, check you can do this on your calculator. Really common that people make errors and put it in their calculator incorrectly. So I'm typing it as I speak, close the brackets, and I get 7.67238469, which I'm going to say is approximately 7.67 to 2 decimal places. I've shown my working, I've rounded my answer, I've shown my accuracy. I'm happy with that question. Next question. Given that, and it gives me a function, find f of 3. Okay, so this one's not too bad, is it? So basically it's saying put 3 into the thing above. So that's going to be 2 times 3 plus 1. 2 times 3 is 6, add 1 is 7. So the answer to this one is just going to be a 7th. Not terrible. I've got a second part over here. So write down the value of x for which f of x is not defined. Well, f of x is not defined where there is no answer. And the thing I can't do is I can't divide by 0. So in other words, it's saying which value of x gives me 0, and that value is going to be minus a half. So therefore my function is not defined, or I'm going to put not defined, for x equals minus a half. In other words, there is no value because you can't have infinity, it doesn't exist. Next question. By using the completing the square. So this is being very specific about what it wants me to do. So it wants me to complete the square, find the coordinates, and again, coordinates, not just the x value, of the turning point. So I'm going to complete the square fully, because that will give me the answer in one go. So that's going to be x minus 12 over 2 is 6, so x minus 6 squared, minus the square of 6 and minus 3, which is going to give me x minus 6 all squared minus 39, which means, now knowing how to interpret this is often one of the last things again you come across in GCSE. I have to say I teach this quite early on because I think it's such a good useful skill. But either way, the answer is going to be 6 minus 39. And why is it that? Because the thing that makes this bracket here equal to 0 is 6. And if it equals 0, the smallest number I can have is minus 39. So that's going to give me the vertex. Next and final question today. The first 5 terms in a quadratic. So it tells me it's quadratic, which means I can assume certain things are going to be true. So let's walk through this. So first thing, as with any sequence really, what's my difference? So my difference is going to be 3, 5, 7, and 9. Which means my second difference, so my second difference, little delta symbol triangle means second difference, is equal to 2 divided by 2, which is 1. And then I'm going to do it my way. Now, this is the first time you watch one of my videos. I may not do it the way your teacher does it. So your teacher might use something like a plus b plus c and was it 3a plus b? I used to teach that, but I've stopped doing it that way. I now do it the constructing way because I think it helps you build it up and understand it slightly better. So I'm going to do one lot, so this one here, so one lot of n squared underneath. So if that number was 2, I do 2 lots of n squared, etc. So 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. And then I'm going to take it away. So 8 minus 1 is 7, 11 minus 4 is going to give me 7. 16 minus 9 is also 7, and that is also 7. What I've done is I've started with a quadratic sequence. I've taken away the quadratic part, and that just leaves me with a linear sequence. And in this case, this sequence is just the number 7. So therefore, my answer is going to be that un is equal to n squared plus 7. Nice question. And actually, that's a good question because it catches some people out because it hasn't got a term in between. However, again, I'm not done, am I? So it says find the first term in the sequence which is greater than 400. So I want to know where n squared plus 7 is equal to 400, which is going to be where n squared is equal to 393. If I get my calculator out, well, that tells you that n is approximately 19.8242, etc. I don't really care about all the numbers. I just care that it's 19.8. Let's write that without the extra decimal point. So 19.8, which means that's the term, which of course you can't have half integer terms. You have to have integers. But that's the number that gives me exactly 400. So therefore the number that gets me above 400 is going to be the 20th term. And that is today done. Question done today. Nice little question there. As ever, I think a fairly good mix of questions. We're getting to the end of the month now, and this month has been much, much trickier. Do like and subscribe. See you tomorrow.